Okay, sir.
Okay, so you don't worry about the notes. It will be available with you by the end of this module. So you just try to understand everything what we are now learning. Okay. So all you are having that syllabus part or syllabus you are having or not? Actually, we are in the covered your steam power plant, air compressor, IC engine parts. Okay. So today we will discuss that refrigerator and heat pump part. Okay. So this is our last part of that module. Then we will shift to module 3. Voice is audible.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Actually, you can see I am preparing the notes for yourself. Where is PME? This one. Actually, this is the module 2. You can see. Okay. This air compressor module 2 air compressor part is over. Okay. You can see it. Its working is over. Internal combustion engine I have already updated. It is not a vertical. It is vertical.
तो
Okay.
डंडा बाइक जाओगे माइल लाग बनेगा
Hey, mute yourself. Mute your. These are the parts. Okay. I've already over. Also, this is your working of our IC engine. Another one is your part. Okay.
Sir, voice clear.
I am not telling anything. Just wait. I come with that rest application part heat engine. Screen is visible.
यस सर
Yes, sir.
Yes, sir.
Okay. So you can see this is actually module 2. I am preparing the notes. Your air compressor part is this one. Let me just zoom it. No, it's not zoom.
नोट्स के अभी लिखना पड़ेगा क्या
अरे हम दे देंगे तुमको अपडेट कर लोगे लिखोगे क्या बैठ के अभी लिखोगे या समझोगे इधर हैं लिखोगे तो 5 6 क्लास और लगेगा तुम हम दे देंगे तुमको ठीक है और नोट्स के बारे में
ओके सर
ये वाला नोट्स है सब ठीक आपके लिए बन रहा है ये सब समझे
हाँ सर
ये बन रहा है आपके लिए देख रहे हो
Yes, sir.
ये खत्म हो गया लिखना और एक सिर्फ स्टीम पावर प्लांट बचा है ये जब खत्म होगा मैं शेयर कर लूंगा समझे तो चलो हीट इंजन और आज हम पढ़ेंगे रेफ्रिजरेटर हीट पंप पिछले क्लास में बोले थे आपको मॉड्यूल 2 सुनो सब जो बोल रहे हैं एक्चुअली नोट्स आपको मिल जाएगा आप सिर्फ समझो एक बार कि शूज रहेगा तो हमको सिर्फ समझ लेना है और नोट्स आपको आप बाद में एक बार मिल जाएगा तो प्रिंट आउट कर लेना है नहीं तो अपडेट कर लेना है अपने नोट्स में Great. Refrigeration. We are discussing refrigeration system. Okay. So here in this class we will discuss operates the thermodynamic cycle and does certain amount of work, amount of positive work through network transfer from a high temperature body to low temperature. Okay. ये खत्म हो गया है. So refrigerator देखो नीचे जो लिखा हुआ है इसका definition है कि that device which operates in a thermodynamic cycle maintains the temperature lower than its surrounding. In a your heat heat pump is similar to refrigerator. However, the required output is desired output is different. There's the expression of your COP of a heat pump and refrigerator. Okay, so desired effect is change in both these cases. There is it is cooling effect and it is aerating effect. Okay, so what are the main components of the refrigerator? You see here now. This thing we will discuss today. Okay, who can tell what are the main parts written here? Who can read loudly all the main parts?
Sir, con
Read it.
expansion valve, first compressor, condenser, expansion valve, evaporator.
Very good. So in evaporator, there are actually four main parts of your refrigerator. Okay. So basic five components are evaporator. Actually here it starts from evaporator actually. Evaporator, compressor, condenser and expansion valve. Then another thing I tell that the system, the refrigeration cycle your refrigerant is flowing. So what is the main purpose of evaporator? The main this is this part of the refrigeration system that does the cooling inside the refrigerator. Okay, evaporator. Its function is to absorb heat from the refrigeration system from the inside, which then radiates out of the system to the condenser. Okay, the evaporation coil present inside the refrigerator where we put our items to be cooled. In compressor, then you can see what happens in the compressor. Okay, so compressor draw low temperature, low pressure vapor from the evaporator. Okay, so what is the refrigerant after that evaporator? It passes to that compressor. Once it is drawn from evaporator, okay, it is get compressed there, and when that low pressure, low temperature, my voice is clear or not?
Yes, sir.
Clear. Yes, sir. Yes, sir.
So what I am telling, like that steam power plant, what is the condition of what was the condition of steam? So similarly here I am explaining what is the condition of refrigerant. Okay, the fluid which is circulated through the refrigeration system is called your refrigerant. We will discuss what are the refrigerant. Okay, later. So you see, once that evaporator, after that evaporator, that low pressure, low temperature, okay, vapor from the evaporator goes towards your compressor and there it is compressed. So when vapor is compressed, its temperature also increases. So now that is after that compressor, it will supply to that condenser. Condenser, as you know, that is act as one type of heat exchanger. It will radiate. That means the refrigerant will radiate all the heats from it. Okay, the temperature now it becomes less after that rejection of heat. Okay, then it passes through that expansion valve. Okay, so you can see that before evaporator that the expansion valve is there. Okay, so the high pressure liquid reaches the expansion valve because temperature before that expansion valve, if you are telling that it is condition of that refrigerant is low temperature, high pressure. Okay, because in the condenser it rejects the heat and its temperature gets lowered. Where the low temperature, high pressure refrigerant now available at the inlet of expansion valve, and that high pressure liquid once reach at expansion valve coming from condenser, there is a valve, expansion valve. We have already discussed like that throttling process in our past law from an nice applied to steady flow process. We have considered a steady flow device. It is your throttling device where there is an orifice or maybe one valve is placed. Okay, throttle expansion valve. The valve reduces the pressure of the refrigerant. Okay, so on reducing the pressure, the temperature of the refrigerant also further decreases and to a level below the surrounding air. Mm. Now, what is the exit condition of expansion valve? Who can tell? What is the exit condition of the refrigerant after expansion valve? What is the exit condition of refrigerant after expansion or expansion valve? Ritam,
Sir, can you please repeat the question?
question is that what is the condition of refrigerant after expansion valve? Am I audible or not?
Yes, sir.
Yes, sir.
What is the condition of the steam after expansion valve?
The pressure should low.
Yes.
Pressure
Any
कम
other?
होगा
Any other? Low pressure as well as low temperature.
low
Isn't it?
temperature.
Yes. So that low pressure, low temperature liquid is then pumped into the evaporator. Okay, or supplied to the boiler. Sorry, no boiler, it is evaporator. Okay. So before evaporator, the condition of the refrigerant is low pressure, low temperature. After evaporator, your low pressure, high temperature. After compressor, it becomes again high pressure, high temperature. After condenser is why
What's
the
the need?
why the
Refrigerant is compressed.
compressed. I'm not audible.
Yes,
Your
sir.
voice is not audible.
Sir, why the refrigerant is compressed? What is the need to
You
compress
think that
refrigerant?
compressor should be there should be no compressor.
No, I don't think so. But I don't know what is the use of compressor.
What is the function of compressor? You tell.
Pressure for high. Pressure the refrigerant.
No, no.
It drops the pressure
Let
of the
him to answer.
refrigerant.
Let it
It
is.
drops the compressor of refrigerant.
Oh, what you are telling it drops the compressor of refrigerant. What does it mean?
It drops the pressure of the refrigerant, sir.
Who can tell? Third, consider the main parts of your refrigeration system. Here, compresses the pressure by reducing the volume. Okay,
Yes, sir.
get it or not? So the refrigerant fluid enters the compressor as a low pressure and low temperature, and then it leaves the compressor at a high pressure, high temperature. Okay. Then after passing through condenser, it rejects heat to the surrounding, so its temperature gets dropped. But about pressure, so that's to reduce the pressure, it has to be passed through expansion valve. Okay,
Yes, sir.
get it or not?
Yes, sir.
Yes, sir.
So all these are the main parts of your refrigeration system. Once if you start with evaporator, then compressor, then your condenser, then there is a expansion valve. Okay, so based your refrigeration system, your basically air refrigeration system, vapor compression refrigeration system, and vapor absorption refrigeration system are there, but this diagram is the of vapor compression refrigeration system. Okay, so if we consider the working, okay, here the low pressure, low temperature, low pressure vapor is refrigerant is compressed by the compressor to a high temperature, high pressure. Then it is condensed into a condenser at a constant pressure. Then it passes through the expansion valve, where because of throttle action in that expansion valve, its pressure also reduces. Hmm. Then it passes through an evaporator, and when it passes through evaporator, it extract heat from the space needs to be cool. Okay,
cold.
and cold. And when that heat extraction takes place or that heat absorption takes place, your space becomes cool. And after that means the heat extracted this into your low pressure vapor, cycle repeats again and again. Okay. So in this system, in this whole arrangement, you can see that compressor requires a work input. Okay, as it is a work consuming device. So in compressor, that means to run refrigerator, the work is need to be supplied to the system. And during condensation, in condenser, heat transfer to the surrounding. And during evaporation, heat is extracted from the space. Okay. And if you consider that expansion valve, there is no exchange of heat during throttling, and through expansion valve, as it is occurred at a constant enthalpy. Okay. So this is all about your refrigeration system with its main parts and its working. And this is the schematic diagram of your vapor compression refrigeration system. So how we can calculate COP, or COP is a performance measuring parameter of your reverse heat engine, as already discussed. And the refrigeration system is a reverse heat engine. You can tell as it works on the second law of thermodynamics. Okay. So if you calculate COP, COP stands for, who can tell?
Coefficient
Who
of
can?
performance.
Very good. So COP can be calculated as it is a refrigeration system. So desired effect by work input. So desired effect is your cooling effect. And that cooling is produced once the heat is extracted from the space needs to be cooled. Get it or not? So that means here,
Yes,
what amount of heat is extracted in the evaporator, that is divided by work input to the compressor. This way you can calculate COP of vapor compression refrigeration system. You get it or not? सब
yes,
समझेगा नहीं रे?
Yes, sir. Yes, sir.
Yes, sir.
Yes,
So
sir.
only you concentrate on this diagram. Once question will come, suppose refrigerator part, you have to draw this diagram. Main parts are evaporator, compressor, condenser, expansion valve. Remember, then you can explain it. Okay. So if you compare your, if you find what is the advantage of vapor compression refrigeration system, it is having higher COP value. Okay. It has a low running cost. Okay. If you can write, suppose a question will come, write advantage of vapor compression refrigeration system, you can answer this way. So most important thing that actually which causes cooling in this refrigerator is your refrigerant. Okay, so you have to know what is that refrigerant. I already told you from the previous class that you have to come with a, what is that types of refrigerant. What are the types of refrigerant? Who can tell? अरे पढ़ के आए हो या नहीं?
CFC,
CFC. CFC means
chlorofluor,
Very good. Chlorofluorocarbon. Okay, so basically refrigerant are classified into following classes like halocarbons, inorganic refrigerant, geotropic refrigerant, and hydrocarbon refrigerant. Halocarbons refrigerant are synthetically produced and were developed by Freon family of refrigerants. So CFC means chlorofluorocarbon, HCFC means hydrochlorofluorocarbon, and HFC means hydrofluorocarbon. So like ammonia, R22, R134A. So in your refrigeration system, in what is the at the home, what we are using that refrigerator, it is a vapor compression. That's why we have discussed that vapor compression refrigeration system. समझे या नहीं रे?
Yes.
Yes, sir.
हाँ, आप आपके घर में जो रेफ्रिजरेटर है उसमें आपको किधर कंप्रेसर है किधर एक्सपेंशन वाल्व तो नहीं दिखाई देगा आपका कंडेंसर आप आइडेंटिफाई कर सकते हो या नहीं
Yes,
Yes,
sir.
sir.
कंडेंसर अरे योर रेफ्रिजरेटर व्हाट इज योर आप घर में जो रेफ्रिजरेटर है कंडेंसर किधर है देखे हो
Yes, sir.
अरे किधर है बताओ
Back side.
Back side. Back side.
वेरी गुड हाँ बैक साइड ऑफ योर रेफ्रिजरेटर देयर इज a coil type arrangement of pipes is there that is called your condenser compressor देखे हो
उसके
Yes, sir.
नीचे होता है.
Black box
वेरी
shape
गुड
का.
उसके नीचे एक ब्लैक कलर का रहता है उसी को बोलते हैं रेफ्रिजरेटर कंप्रेसर
Compressor.
एवापोरेटर जो होता है आपका जो जहाँ पर आपका ज़्यादा कूलिंग होता है टॉप पार्ट में जिसको जिसको बोलते हैं वहाँ पर जहाँ आइस करते हो बनाते हो उसके ऊपर दिया जाता है समझे सो एक्चुअली अर्लियर जो आपका रेफ्रिजरेंट यूज हो रहा था R22 R123 बट एज फॉर द in 19 from 1987 okay actually there is a global agreement body is formed with lateral effect it is Montreal protocol okay Montreal protocol there is some ban on using some types of refrigerant okay as it is depleted the ozone layer that's why refrigerant like your so the refrigerant not used earlier to the used that is
Sustainable.
hey mute your audio
साथी बहन तो नहीं है. साथी बहन तो नहीं है. उन्हें
Tajib
कैंसिल हुए. एग्जाम में क्या नाम है? एडमिशन कैंसिल हो रही है. चेन्नई दुर्लतन. हाँ. साथी बहन सब करने के यार. गिफ्ट कॉलेज में. हम जन कॉलेज में हमारे. तो उन्हें दूसरे एडमिशन कैंसिल हो गए. उन्हें जेम नहीं लगा सुनो. नहीं वो जी दे रहा था.
okay so this is all about your refrigeration system with the it's working so now this is the completion of your module 2 okay So now this is your completion of your module 2. Here we are just discuss the application part of harmonize related to your air compressor. It's working. Steam power plant it works. It's working. Refrigerator heat pump. Its working principle also, and also IC engine. Main parts we describe its functions, terms used in IC engine. Okay. Along with difference between two-stroke, four-stroke, as well as petrol and diesel engine. So this is all about your module 2. Now we will move to module 3. The module 3 contains two parts. One is basic power transmission devices and introduction to robotics. Okay. So in basic power transmission devices, we will discuss the power transmission device like belt, rope, gear drive. Okay, we'll discuss it later, but now we'll start robotics part. Introduction to robotics. Now you can see the slide share with you.
Yes.
We are in module 3,
Sir, module.
robotics. Module 3,
Yes, sir. Yes.
module 3 having two parts. One is the basic power transmission device and the introduction to robotics. So we'll discuss what is robotics, what are its main parts. Basically in your syllabus. But what to discuss, let me. In this robotics, here robot anatomy is there, joint and links, and common robot configurations. These things we have to discuss, and it will take 2 to 3 classes. Okay. So in this robotics, your robot came from a word that is robota, which means a force of slave labor. And you have to remember that definition. Who can read that definition? What is written according to Robot Institute of America? Who can read?
According to Robot Institute of America, it is reprogrammable multifunctional manipulator designed to move materials, parts, tools, or specialized devices through variable programmed motions for the performance of a variety of tasks.
Ah. So you read. I am reading this one. It is a reprogrammable robot. Definition of robot is it is a reprogrammable multifunctional manipulator designed to move materials, parts, tools, or specialized devices through variable programmed motion for the performance of a variety of tasks. Get it or not? यानी कि robot is a reprogrammable multifunctional manipulator basically used to move materials, parts, tools, or devices through a programmed motion. Okay. So next it is deals with manufacturing. Okay. And this term was introduced by Isaac Asimov in the history of 1942. Okay. In robotics, we use the fundamentals of physics, mathematics, mechanical engineering, electronics engineering, electrical engineering, and computers. Okay. So this is all about the definition of robot. So the three laws given by Isaac Asimov, who introduced the term robotics, as per him, a robot cannot damage a human being or nor allow this to be damaged. That means a robot cannot damage a human being. A robot must obey human order, except when these orders clash with the first law. That means first one is that a robot cannot damage a human being or nor allowed this to be damaged. A robot must obey that human order. And last one, a robot must always protect themselves as long as this protection does not clash with his first and second law. That means if first is valid, then second will be valid. If first is not followed, then second will also not obey. So these are the three statements given by Isaac Asimov, named as three laws in robotics. This is called your robot anatomy. Robot anatomy means the study of different joint and links and other aspects of the robot. This one part basically study of that one is called your robot anatomy. Study robot, what are the main parts with its functions, then it is called your robot anatomy. So from this diagram, you can find there is some link is there. Link देख रहे हो सब? अरे link देख पा रहे हो या नहीं?
Yes, sir.
Link or arm. Actually, if you just think about yourself, robot looks like a human being. First, understand this. Like our arm, like our wrist. Okay. Robot is also having arm and wrist. Okay. So you can see various parts like base is there, joint is there, link arm there. Okay. Some drive unit is there and also controller is there. Arm, both arm linked together by a joint. You can see that two link or two arm are joined together by a joint. You can see that joint. Yes or no?
Yes, sir.
This is your main parts of this robot, and if we study about this in detail, this is called your robot anatomy. So you can see that base. आप कुछ कोई कहाँ पर भी रोबोट देखे हो या नहीं बताओ? रोबोट देखे हो अभी तक?
देखे सर सर
कौन देखा है बताओ? कहाँ देखे हो बताओ?
सर मूवी
मूवी में देखे हो रोबोट? ठीक है। रेस्टोरेंट में कहाँ देखे हो? रेस्टोरेंट में देखे हो?
नहीं सर
ठीक है।
कार मैन्युफैक्चरिंग फैक्ट्री और
हाँ, that is there. Okay. So come to the main components. First one is your base. Second one is your manipulator arm. Okay, or robotic arm we can call. There is a end effector. End effector, that means end of arm. You can see it in this diagram or not? अरे आप बेस देखे तो बेस देखे
Yes, sir.
बिल्कुल.
Yes,
यस
sir.
सर
आर्म देखे आर्म
Yes, sir.
यस
जहाँ पर एंड ऑफ आर्म है, एंड ऑफ आर्म एक जगह पर है.
Yes, sir.
हाँ सर
Yes, sir.
हाँ, तो आपके आर्म में एंड में क्या है? आप कोई भी चीज को जैसे पकड़ सकते हो, समझे? उसी तरह रोबोट के आर्म के एंड में भी कुछ ऐसा चीज है जो कोई चीज को करने के लिए, किसको होल्ड करने के लिए, समझ रहे हो या नहीं? तो उसको बोलते हैं आपका एंड इफेक्टर और ग्रिपर, समझे? सो यू कैन सी द मेन पार्ट्स आर बेस. बेस देख रहे हो तो बेस कैन बी फिक्स्ड और मूवेबल. आपका जो रोबोट बेस होता है वो फिक्स्ड हो सकता है, नहीं तो मूवेबल हो सकता है. मैनिपुलेटर आर्म जो है वो कैसे फॉर्म होता है, वो लिंक देखो, दो लिंक ज्वाइन हुआ है थ्रू जॉइंट्स। सो लिंक एंड जॉइंट्स वो अगर मिलेंगे तो आपका आर्म फॉर्मेशन होगा। तो वहां पर एक दाएं साइड में लिखा हुआ है, राइट साइड में देखो, सेवरल डिग्रीज ऑफ फ्रीडम। डिग्री ऑफ फ्रीडम, हु कैन टेल व्हाट इज डिग्री ऑफ फ्रीडम? अरे बता सकते हो या नहीं?
So free to move in every angle.
फ्री टू मूव इन डायरेक्शन, ओके।
Yes, sir, in every direction or maybe some angle.
तो ये जो लिखा हुआ है सेवरल डिग्री ऑफ फ्रीडम, मतलब वो ऐसा डायरेक्शन में मूव करता है। कोई एक्स एक्सिस में मूव कर सकता है, नहीं तो वाई एक्सिस, पॉजिटिव वाई नेगेटिव वाई, पॉजिटिव जेड नेगेटिव जेड। हाँ, वो रोटेशन भी कर सकता है या नहीं? आप आपका जो ग्रिपर हाथ के आर्म के एंड में जैसे है, आप उससे वो नहीं कि ऑफ डाउन कर सकते हो, मूव कर सकते हो या नहीं? उसी तरह का रोबोट भी कर सकता है। तो ये कैसे करता है? बिकॉज ऑफ दैट मैनिपुलेटर आर्म। तो एंड इफेक्टर क्या होता है? देखो नेक्स्ट पार्ट होता है एंड इफेक्टर। एंड इफेक्टर अगर आप नहीं पहचान पा रहे हो, देखो इन दिस डायग्राम you can see at the last end of your arm or link there is a end effector is there. Okay, so what is the function of end effector? End effector function is to hold a part or two rotational joint. These types provide rotational relative motion between axis of rotation perpendicular to the axis of input and output link. Rotational, twisting and revolving like that. Then this is the actually manipulator configuration is there, TRT. TRT means stands for your T stands for translational motion, R stands for revolute or rotational motion. Then TR configuration, if question will come in this way. Okay. So what is that VTR configuration is also possible. RRT configuration also possible of that robot. Then this is the end effector. End effector is a device attached to the wrist of a manipulator for the purpose of holding materials, parts, tools, or to perform tasks. So that part of the robot which is attached to the wrist to hold material, parts, or tools is known as your end effector. It is of two types. One is gripper, another is tool. So end रोटेशनल मोशन पॉसिबल को देखते हो, ठीक। राइट या लेफ्ट कर सकते हो। राइट और लेफ्ट मोशन को बोलते हैं आपका, वन इज मूवमेंट, या इज द लेफ्ट एंड राइट मूवमेंट, एंड रोल इज द रोटेशन ऑफ दैट हैंड। गेट इट और नॉट? एनी क्वेश्चन?
नो सर।
समझे तो?
Yes, sir.
यस।
Three types of rotational motion, you clear or not? Pitch, roll and yaw.
या
pitch बार बार बोल रहा हूँ। आप अपना हाथ हाथ जो पाम पोर्शन है उसको देखो। If you get it, the motion, आपका पाम आप अप डाउन कर सकते हो या नहीं? अरे
Yes,
कर
sir.
सकते हो तो?
Yes, sir.
यस सर।
तो ये मोशन को कौन सा मोशन बोलते हैं? कौन सा?
Yeah.
या
Then roll is just a rotation of your palm. You get it?
Yes, sir.
यस सर।
So this type of motion by end effector. End effector is attached to the wrist and wrist is attached to the end of the arm. तो फर्स्ट फिगर को चलो अभी समझ में आएगा। देखो जो wrist है देख रहे हो, वो आर्म के एंड में है या नहीं? अरे आर्म के एंड में
Yes, sir.
रिस्ट है या नहीं?
यस
जो
सर,
Yes,
Yes,
रिस्ट
sir.
के
sir.
Yes,
आगे,
sir.
यस सर,
रिस्ट के आगे जो
Yes,
है
sir.
एंड इफेक्टर है। रिस्ट के आगे जो है उसको बोलते हैं एंड इफेक्टर। तो कौन बताएगा एंड इफेक्टर का काम क्या होता है? एंड इफेक्टर का काम होता है टू होल्ड, यस
Hold
और नो?
the holes.
वेरी गुड। So we'll discuss more from this chapter in the next class. Okay. So like this, lot of
Yes, sir.
parts remaining from here. We'll discuss one by one. Your robot configuration, and then it will. I think this chapter will be over in the next class, and I will also give you the notes. Okay.
Okay, sir.
Give me
Sir,
one. Give me 1 day's 1 day. I think tomorrow is Sunday. I will give you the complete module notes of the second module notes on Monday. I think. As you already seen it, I have already prepared for steam power plant. So I will share with you in the next class.
sir,
Just wait for the attendance. Any question?
सर कला माउस स्टूडेंट्स का लिस्ट मिल सकता है मुझे? सर कुछ लोग ऐड करने के लिए बोल रहे हैं ग्रुप में और मैं जानता नहीं वो कला माउस के है कि नहीं, इसीलिए सर
And also
कॉन्टैक्ट नंबर।
you are getting it. Pala,
बीटेक कोऑर्डिनेटर आलोक सर,
Pala sir,
बीएमई
Pala
एचओडी।
sir. Hey,
सर कलाम हाउस रे
you are first
कोऑर्डिनेटर।
year coordinator. No, first year
Pallab sir, Pallab.
coordinator. Pala sir. You have to contact Pala sir. Okay. I think he is in this group.
थैंक यू सर। हाँ सर, थैंक यू सर।
Just wait, just wait. Hey, attendance नहीं आया नहीं, thank you कौन? Attendance दो मंडल।
Present, sir.
अरे मंडल टोपो,
Present sir.
हसन रजा,
Present, sir.
अरुण अरुण आया है रे, अरुण सोरेन कौन?
सर
नहीं।
वो कौन पता
दीप
नहीं है।
और दीपक बेहरा, दीपक बेहरा नहीं है। ओके, अभिनंदन
सर अभिनंदन दास हॉस्पिटल में अभी।
क्या है, क्या हुआ है?
नहीं, वो बोल रहा था उसकी मम्मी की तबीयत खराब है इसीलिए।
और ठीक है, अभिनंदन नहीं है, आदर्श, आदित्य बेहरा
यस सर।
नहीं है।
Yes sir. Aditya.
आदित्य बेहरा जी, अरे यो बोला था पिछले क्लास में ना, आपको सीरियल नंबर लिख लेना।
Yes sir, लिखा है
आलोक,
मैंने।
आलोक कुमार, आलोक कुमार बोलो। नहीं। अमन आनंद,
Yes sir.
अमन आनंद, अमित कुमार, सुनो, रोल नंबर 6 से लेके 30 तक
19,
है। सीरियल नंबर बोलो।
सर
15, 12,
सर
21
19,
24, sir, 24, sir, 12,
सर
sir,
24,
23,
सर
23,
30, सर
keep
30 कोई
silent,
सी
keep
21।
silent।
सर 9,
21,
सर
23,
सर
23,
30,
sir, 27,
सर 30,
27,
sir, 12,
सर 30,
सर 9, सर 9,
26
46 sir. 46.
है। 46 कौन?
30,
ମୁଁ ତମକୁ କହିଲି 30 ପର୍ଯ୍ୟନ୍ତ।
सर 9,
हैं?